Hi class, welcome to our end of the year project. We have something fun planned for you, but we have to go through our notes first. First, we have the 5 sampling techniques that are up there on the screen. Next, we have our weighted average, in which we have an example relating to cars and the number sold and their prices. Basically, you have to divide by the number of units sold, and then you have to add in the price, and you can find the sample mean for all of them. Next, we have qualitative versus quantitative variables. Qualitative is basically a characteristic, and quantitative is a number. In Unit 2, first we learned about mutually exclusive / disjoint sets. A real-life example of mutually exclusive sets is called tossing a coin, in which we put an example up there, as well as weather forecasters assessing how likely there will be rain, snow, clouds, things of that nature. Unit 3, we learned about confidence intervals for mean, Chapter 7. We have the confidence interval formula up there. We have the margin of error formula. We also have an example that relates to social networking sites. You can see the confidence interval, true, mean. You guys know how that works. Next, we have normal distribution and skewed data. Normal distribution is bell-shaped, both sides approaching 0. At the top, it's the highest. You'll find most of your probability data there. A real-life example of how this works would be flipping a coin. There's a 50-50 chance, so the distribution of odds is all equal, which is what it shows in a normal distribution graph. Unit 4, we had hypothesis testing. It's basically a method for testing a claim or hypothesis about a parameter in a population using data. For hypothesis testing in Chapter 8, we figured out how to make the different hypotheses. We made the null and alternative. We identified the claim. We learned the z-test and t-test formula. And then we have an example there of what that looks like. Next, we have more in-depth formulas for the z and t-test if you were to use them manually. And then we have these symbols for the null and alternative when we were thinking of two-tailed, right-tailed, left-tailed. We also learned dependent groups, pre- and post-assessment. Next, we have a formula, another formula for the t-test, and then more hypothesis symbols. We have an example of what that would look like underneath. Next, we actually learned ANOVA testing, which you use for 3 or more groups. You use your hypothesis, you use your critical value, which you find on the F table, and then you plug that into an online calculator. Lastly, we have our real-life example for ANOVA testing. We compared it to essential oils. Since there's so many on the market, you would have to do your own research and probably use an ANOVA test to figure it out. Thank you guys for sticking with me as I went through our notes, and we are going to have a Fran broadcast in 3, 2, 1.
What's up, guys? It's Ava with Fran's News reporting to you live. We have some very interesting stories today. First, it's going to be by Austin, learning about some hypothesis testing. What do you have to say about hypothesis
Give
testing?
me that. Come over here. So I was in Forrest's backyard. We was browsing, and I saw that he was growing these cucumber plants. And he told me they planted them at the same time. So I decided, which one's growing faster. So right here, as you can tell, we got a Japanese cucumber. I don't want to pronounce that name. Cultural appropriation. The next one, heirloom straight 8 cucumber. So I measured both of these plants. This one's a little slower. That one's probably about 1 inch off the ground. You can't see it, but it's under there. This one's probably about 3 inches off the ground. So I used the 2-prop z-test and compared it to samples across the world to see if my plants right here were accurate to the normal data. With 2-prop z-test, I was able to determine with a p-value of 1.3 that I couldn't say for sure that my plants were growing faster than the other ones, simply because my p-value was lower than my 99% significance level, which would be 0.1. Thank you. That's all I have to say. Now, there's different advantages. You
Okay.
said, okay.
We're good with that.
All right.
Let's keep going. Hey, Riley, you got a story for us?
Indeed, I do. Unfortunately, we're gonna need a 3.0 GPA to pass high school right now. And I gotta calculate the weighted GPA, or the weighted mean of my GPA from Unit 1. So here we have 4 classes. I have a 4, which is an A in math. I got a 3 in history, which is a B. I got a 4 in health, which is an A. And I got a 2 in art, which is a C. God dang. Okay, so the units, I got 5 for math, 3 for history, 2 for health, and 2 for art. So what I need to do here is I need to time the grade points versus the amount of units to calculate the grade point average. So what we do is we times all those together, and then we add up the amount of units to get the weighted average. And if we put all that together, I'm finishing with A 3.42, which means I'm graduating high school, baby. Let's go. Let's go.
Thank you for that. Let's keep going.
And it seems like we're getting word in from our correspondent, Nate Newton. We're going to see what he has to say. Thank you.
In a standard deck of playing cards, there are 52 cards. Assuming that every single card in the deck is different, there are 52 factorial different ways that you can arrange these cards. 52 factorial is 52 times 51 times 50 times 49 all the way down to 1. That means every time that I shuffle this deck of playing cards, that is probably the first time that the deck has been in that order. Pretty crazy, huh? Now I know you're wondering, Nate, which shuffle is the best? And oh boy, do I have the answer for you. My shuffle. My shuffle's the best, if you were wondering.
All right, I'm unsure of whatever that was. Thank you, Nate, for your help. Now back to our regularly scheduled programming.
Forrest with the weather.
What is up to my viewers of the Fran News Network? It's your favorite section of the day, the weather. Now today on a fine June 5th afternoon, the high is 93 and the low is 74. It is hot and breezy. And according to my calculations, the chance of sunshine is 93%. Now tomorrow on Monday, yeah, I know it's Monday, but today, Monday, it's hot. With a high of 92 and a low of 71, it's gonna be humid. I know we're in Portland, Oregon, but it's gonna feel like Hawaii. With a chance of sunshine at a 94%, yes, 94%. Now, on a Tuesday, it is still gonna be very hot with isolated storms. With a high of 90, with a low of 71. It's chance of rain during the morning time of a 50% chance of rain. Now, going to Wednesday, there's going to be some isolated storms again. It's going to be just like Tuesday. It's going to have some rain in the morning with a high of 90 and a low of 70. Now, going to Thursday, you have, another isolated storms. The weather is going to go a little lower with a high of 88 and a low of 70. Now, the chance of thunder, it is 33%. Now, on Friday, it's going to be just like Thursday. And you know how it's kind of repeating, I'm not going to lie. But it's going to have scattered storms with a high of 88 degrees and a low of 68 degrees. And the chance of rain is 45%. Now, on Saturday, Saturday, there's only going to be a few storms. And the high is 87 and the low is 66. With a chance of rain of 2%. So, man, go to the water, go to the lake. It's gonna be sunny out, and I'm headed out.
Thanks for the weather, Forrest. Lastly, back to Austin for some normal distribution.
As you guys can see here, I've got my two guys right here flipping coins for me. I've been trying all day to disprove normal distribution, actually. I felt that you could get 5 tails in a row just as likely as others. Turns out I was wrong. As you can tell, there's about even numbers on both. If they were to do about 10 tails in a row, then we would be pretty close to disproving normal distribution. But they seem to just keep getting they're alternating. Heads, tails, heads, tails. So on the graph, if they were to get 10 tails in a row, they would be approaching 0. As soon as you approach 0, it seems that these resets, and that's just the law of normal distribution because there's a 50% chance of both heads and tails. That's all I've got today. I appreciate you guys for tuning in. I might have to give them a weighted coin soon or something. I might have to fudge my studies here. Riley, can you do it for me? Nope, he sucks. All right, thank you.
R.
A.
In the spirit of Nate.
And
That's the Fran Network.
Signing off.
peace.